Hello. In this video, we're going to go over grid-in problem solving that can show up on the no calculator exam, though a problem like this could very likely show up on both math sections of the SAT. In a right triangle, one angle measures degree x, where sine of that degree x equals 4 over 5. What is cosine of 90 degrees minus x degrees? Well, this definitely seems like a scary problem for a lot off the bat. I can certainly understand that. So the best thing to do is start drawing out what you're seeing here, a right triangle, right? Which means that we know there's a 90-degree corner right here. There's only 90 degrees left between these other two angles, and I'm just going to call this one here x. And I see here that it's asking for sine of x being 4 over 5. And if we use SOHCAHTOA, what we see is that these are acronyms, SOHCAHTOA, explaining to us what sine, cosine, and tangent are. So sine of an angle, in this case, might as well call it x since that's what they're asking for, equals opposite over hypotenuse. And I look across from x to see what the opposite is. That's right here. And that's telling me that it's going to be 4, because what they're telling us is that the sine of x is 4 over 5. So that means this opposite here is 4, because it's also the numerator, and then the denominator shared here is 5, which is the hypotenuse. So it has to be this. Let me do this in red just so it's a little bit more clear. The hypotenuse has to be right here because 5 is across from that 90-degree angle. So 5 has to be the hypotenuse in reference to the whole triangle, actually. That's a universal measurement for this triangle. Okay, so what is the cosine of 90 degrees minus x degrees? So what does that even mean? Well, 90 degrees is what was left over after we realized that this corner here is the right part of the triangle, the 90-degree triangle. So there's only 90 degrees left between here and here. So seeing that 90 minus x, it means that really what you're left with is just this part of the triangle. You can also think about it in the sense that we already know that this is 90 degrees. We already know this is x. So whatever fancy name they came up with here has to be something else. And so we'll just call this y. Cosine of y. And what is cosine? Well, ca tells us, let me move this over here a bit, that, whoop, heyo, there we go. Cosine here is going to be of, let's just say y, it's got to be adjacent over hypotenuse. Now, whenever, this is y here, whenever we're thinking about what is adjacent to a particular angle, it's easy to have that confused with the hypotenuse. If you see here for y, it has two legs that are connected to it, right next to it. So it's easy to have them both confused as adjacent. But the best way to know which one for sure is by identifying the hypotenuse first. The hypotenuse, like we said, has to be across from the 90 degrees. No matter which angle we're looking at here, whether it's y, x, or even the right corner here, that 5 has to be the hypotenuse. So it cannot be 5, and then now you're left with 4. So adjacent has to be 4, and as we just said, hypotenuse must be 5. Thus showing us that the answer is actually 4 over 5, the same number that we see here. That actually doesn't come up that often, but it's a nice break to have. And so what I'll do is, let me not break my methods here, 4 over 5. And I'll just go ahead and bubble that in. The SAT would accept 0.8 if that's something that you're more comfortable with. If you see numbers in regards to decimals more naturally, then that's perfectly fine. But if this is the approach that you take, there's no need to spend extra time converting or anything like that. But 80% or 0.80 is another answer that they would accept. Best of luck. Let me know any questions. You can do it.